This is a short video segment on some of the post-processing aspects of the 3D Experience Release 2022X. The, the concepts are very simple. I mean, obviously, there's nothing complicated here, but it's rather awkward to find some of the features that you may be looking for. The specific thing that I want to look at is the contour plot, which allows you to plot different things, such as von Mises stress or displacement, etc. And obviously, in order to do the contour plot, the software must have run. You will end up in the results, which is, think about it as being post-processing module, and then you select the plots tab if you're not already there. And one of the things that we are interested in this, specifically in this tutorial, is this contour plot icon. As I said, the purpose of this video series is to introduce some of the things which are very simple, and ordinarily in some of the other software there may be sufficient documentation or perhaps some tutorials on YouTube which allows you to do it. In the case of 3D Experience, using the FEA module of it, it is gradually expanding, and that's really what the purpose of this video and the ones similar to it are, as far as I'm concerned. Okay, so the model that I'm going to make is very simple. It's going to be basically a box. It's going to be a cantilever beam. And we just want to generate some results so that we can actually go ahead and fool around with these different settings. Okay, so let me go ahead, and here's my CATIA my CATIA partisan interface. So I'm going to make a cantilever beam. So on this plane, on that YZ plane, I will sketch a square which is maybe 2 centimeters by 2 centimeters. So 2 cm. Okay, same thing here. 2 centimeter. Exit and pad it by let's say 20 centimeters. That's how it looks like. The actual dimensions, material properties, and these things do not matter, because all we are trying to do is to look at some of the functionalities that contour plot icon. Okay, so let's go ahead and apply material to this. Create a material. I'll say the bar. The bar. Okay, and simulation domain is checked. Very good. Right, I'm going to use the standard properties of steel. As I said, the actual dimension and the size, they don't matter here. Right here, right click, apply to that part, check mark right there, and let's put our numbers in there. Double clicking on this. Under the structures, abacus multiphysics, mechanical, elasticity, elastic, and 200 gigapascal, right? 200 GPa, and Poisson ratio 0.3. Okay, good. Now we're going to create our mesh. So structure model creation here. Let it do automatically for us. I will make the size of each element point, I don't know, maybe point, see the cross section was 2 centimeter, 2 centimeter. So let's make it 2 centimeter to see how it looks like. Okay. If it's too fine, I'm going to, oh yeah, that's too fine. Okay, so let's go ahead and make this Okay, I changed the size of this to zero point 0.1, the size of the element 0.1 meter. So 1 centimeter, yeah, 1 centimeter size. Okay, very good. So that's fine. All right, so let's move on. Yeah, we're done with our mesh. Let's go to structural scenario creation. I'm going to use the model that I made. Okay, I notice that we are in the structural scenario now. So you click static step, and we're going to do a linear problem because this has nothing to do with linearity or non-linearity. Okay, so just all I did was to go there. If you look at it, all I did was to go there. Sorry, in the step, and I went to the advanced, and I unchecked the include non-linear non linearity for geometry. Okay, include geometric nonlinearity. I unchecked it because what we do has nothing to do with these issues. Okay, good. So let's see now. Under the restraint, we're gonna clamp that end, that face, completely fixed. Okay, and we put some kind of a pressure on the top. All right, so under the load, we're going to take pressure, and we're going to take that, yeah, that surface, top surface, and I put down 100, maybe 1,000 Pascal. Yay. Let me see, something I didn't type right, probably. So let's see under the load, double click, 1,000 big P, little a, 1,000 Pascal. Okay, very good. Now we're going to run. So we go to simulate. First of all, we're going to check the model. That's done. Check the scenario. These are steps that you can skip if you're sure there's not going to be, any errors. So, although in principle, it's a good idea to check them because sometimes you get a message, you don't know what the issue was, but if you do these before you actually run it, there are good chances you can catch them and fix them. Okay. It'll be done very quickly. Okay, good. This is done. And now we're going to run. Nothing exciting is going to happen. This is going to bend, obviously. And then we want to do some post-processing and find out with that contour plot, what is it that we need to, what is it that we can do? Issues like this, if you use 3D experience on a regular basis, obviously you're going to get it. There's nothing, as I said, there's nothing complicated here. It's just that I'm trying to help and save you some time. That's pretty much it. If you are a intermediate or advanced user, obviously you don't need these tips or videos. Okay, good. So this close this thing. This is the this was the initial step. Obviously, nothing happened. There is the uh, final step after you apply the load. Now, first of all, notice a couple of things here. So one of the reasons that it looks so ugly is because my mesh was coarse and I'm using probably linear elements. So that's why this doesn't look very good. As a matter of fact, let me go ahead here and change my mesh from linear to parabolic. Yeah, there's some improvement there. And yes, in fact, let me make this thing also 05. And we're going to run it. I'm not going to check it, so we go to right there, scenario. Under scenario, and we're going to run it. all I did was to went to my model, chose a finer mesh, and made the element parabolic. Although with this finer mesh, I really could have left it as linear. It's not going to make any difference or much difference. Up until this point, I haven't shown you anything that's relevant to this particular video. I'm going to do that now. Good. Okay, so now you can see that makes more sense because the uh, the maximum stress should be at the wall. It is. This is the von Mises stress, obviously, and you can look at yeah. So that's fine. You can look at the deflection. Is displacement. The biggest displacement is at the free end. You can see that right there. And it really doesn't matter which one of these we work with. So let's start with the displacement. All right, first of all, if you double click on this legend, if you double click on the legend, left click double, so you get this dialog box opening up. And there are certain things that you can do here. For example, notice that it says smooth color. See how smooth it is? So we say okay, uncheck it, and say close. You see, now the variation is not smooth. There are distinct colors that's going on here. Now, if you want to put it back, you just double click on it and say smooth color, close. See, now it's smooth. The other thing is you look at this and there is a reverse color. So blue becomes red, red becomes blue, etc. So if that's what you want, which ordinarily for a deflection or ordinarily you want red to be the biggest things, okay? Now there are some other issues here which I'm not going to worry about it because that was not really the purpose. Okay, so if you click, notice that you are in results, select a plots tab, it is already selected, and there is the icon that I'm going to fool around with. You click on it, okay, let's move this thing on the side, make this thing a little bit smaller. Now there is, see there is an options here, see that right in the middle, there is an options. You click on the options, few things. There is no node numbers here. If you want to see the node numbers, you select it and say apply. See that? Zoom in, you're going to see all your node numbers. Now, I have so many elements here that it looks like this. Now, if you also want to see your element number or only your element number, you check this, uncheck that, apply, and these are element number. You see that, okay? If you want to see both, obviously you're going to make them both, okay? Now, the other thing is that here, this check mark, it says, okay, show me the deformed shape. If you don't want to see that, you uncheck it, apply, it shows you the undeformed shape. Now, again, if you want to look at the nodes and things like that, you select it, you apply, but it shows you on the undeformed shape. Okay, very good. The other thing is that you can, so I'm going to leave this thing as it is, show deformation, okay? The other thing is that show deformation, you can change the scale. This is the true scale. If you want, if you want 10 times, if you want 10 times that, apply, didn't make that much of a difference. If you want 1,000 times, apply, notice it did go down, one more, 10,000 times, apply, okay? Or if you want to reset it, just reset it and it's going to go back to the automatically selected scale factor by the software. See, 13,000. Now obviously you can put a zero here, a big zero here, another zero, and this is going to be disaster. So reset, apply. Okay, so we know what these things are. Then we see something here which says threshold. So if I want to display only the stresses, for example, if you like, this is a von Mises stressor I'm looking at, by the way. only the von Mises stress bigger than, let's say, 10,000. No, that would be one, 100,000. Okay, so you're going to say, okay, I want a lower value or upper value. Show me only the stuff up to 100,000. Okay, so let me put 100,000 here. Don't show me anything above 100,000. This apply. There. It is only showing me the stuff that are above 100,000 uh, Pascal. Okay, right there. Okay. Now, if you want to say that, okay, show me only the stuff that are below. So here, change the lower value below. Let's make it uh, below 100,000. Obviously, it's going to show you this stuff, right? The one on the left. There. Okay. It also shows you the maximum. And if you don't want to see that, if you don't want to see that maximum, you can uncheck it here. See that? Show max extrema. Apply. It's going to take away the extrema. Okay. There. Apply. It's going to give you back. The other thing is that this stuff, you can change the transparency of it. For example, grab this sliding bar, say apply. You see that? It changes the transparency of this so that you can see perhaps things better. Let's try the other way around. Lower limit, apply, maybe upper limit. There, okay? So show me only the stuff below 100,000 psi, not psi, Pascal, and the rest of the stuff, change the transparency of it. If you don't want, put it back, apply, and this is what you're going to get, okay? Apply, that's what you're going to get. All right, so these are really the items that I wanted to talk to you about. So if you want to see the node numbers, apply, okay, obviously, there we are. Element number, apply right there. These blue ones are element numbers, yellow ones are node numbers. And obviously you can change these colors and things like that, but that's really not the purpose of this video. What I wanted to show you is what are these functionalities. That's pretty much it. Now you may want to explore these things, this one and the other one, but that was not the purpose. I just wanted to show you the settings in this icon. Good luck.